Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shine, coming to you live from Summit Academy. In this video, working on this unit number 4 wrap up, and it says, here's a balanced hanger diagram. A circle has a mass of 3 grams, and a square has a mass of 2 grams. And it says, which is the mass of a triangle? And so what you can do is, in the pictures that you're given, you can eliminate some of these shapes. Since it's balanced, that means that we can take 2 from one side and 2 from the other side to be able to eliminate them. And same idea with the squares. I can take 2 squares from the left and 2 squares from the right. And then with the triangles, I can take 2 triangles from the left and 2 triangles from the right. So try to eliminate some of these before you do it. Then you could say, well, we know that the squares are 2. So I can put a 2 next to each of these squares. And then we could say, well, if these triangles are what we're trying to solve for, we can put an x by each of them, because that's what we're trying to solve for. So then what I can do is, now using these terms, I can write my equation. So I can say, well, I have 4 x's, so I have 4x equals 2 plus 2, which is 4. Then all I have to do is saying, okay, well, I'm trying to figure out what the mass of one of these triangles is. I'm trying to solve for x. So I do my one inverse operation, divide both sides by 4 to get x by itself. And so I'm going to say x equals 1. For the next one, it says select all systems of equations that have exactly one solution. And what it means by it, one solution is, so it's one point of intersection. So when we go to graph it, that's what we should do first. So let's pull up our graph. And let's say, okay, looking at that first system of equations, I have y equals 4x plus 2. I have y equals negative 4x plus 8. So wherever they are equal is where they intersect. So for that one, I can say it's going to be 0.75, comma 5. So let me write that on here. So I'm going to say my point of intersection, or one solution. I'm going to say, hey, this first one is good if you want to put a star by it or circle it, whatever works best for you, but make sure you label that solution point. So I'm going to say 0.75, comma, and 5. Because when we have our point of intersection, again, an ordered pair is those 2 points, x and y. Alright, so let's try for the second system. We have y equals 2x plus 2 and y equals x plus 2. So same idea, we have one point where they intersect. So what is that point? It's on that y-axis, so it's going to be x equals 0, y equals 2. So it's going to be 0, comma 2. So this one is also has one solution, and we'll say 0, comma 2. All right. On the third one, so let me clear out this one. Again, make sure you're just doing one system at a time. Again, a system of equations, it's at least 2 equations on the same graph. So I have y equals 5x minus 1 and y equals 5x minus 7. And so what I notice is, for these 2 lines, I notice that both of them have the same slope, both of them have a slope of 5, but I'm saying they have different y-intercepts. So I'm going to say that for this system it has no solution. Sorry, this is going to be no solution. Again, we're only picking the ones that have exactly one solution. Alright, looking at that fourth choice, we have x plus y equals 5, and we have x plus y, or sorry, we have 3x plus 3y equals 15. And so notice when I type in that 5, notice how it has the same slope, but when I actually type 15, it actually is overlapping lines, so we're going to say that it is going to be infinite solutions. So for this one, this is going to be, we're not going to pick this one, but we're going to say infinite infinite solutions, because they are overlapping lines. And for the last one, let's check it out. We have 4x plus 4y equals, 4y equals 10, and 4x plus 4y equals 12. So even though they're really close to each other, they don't intersect, and so we're going to say no solutions for that one as well. So no solutions. So only those first two are the ones with one solution. Alright, so let me hide this real quick. Again, a point of intersection has that solution point. So this is solution point, again, as an x and a y value. Okay. For number 3, it says here is a graph for one of the equations in a system of two equations. It says the solution to the system is -1, 3. And it says select all the equations that could be the other equations in the system. So it gives you the graph for one of them, and what we're trying to find is we're saying, well, it has to go through this point. So it has to go through this point, -3, so -1, +3. So -1, +3. That's going to be the solution point to the system. So now we have to figure out, okay, if we graphed out these equations, which of these has a point that is -1, 3. So what I'm going to do is this. So let's pull up our graph, and it says we have to go through the point. -1, 3. So let me label that point as well. So if it doesn't go through that point, we know it's not a solution. So let's try the first one. So we have y equals -3x as our equation, and so this one's going to be good. So we're going to say that one's good. Let me actually I'll leave it up for now. Second one, it says y equals -3/2 times x plus 6. So notice how that one does go through the point. So we're going to say that one is not a solution. So I'm going to get rid of that one. Third one is just y equals 3. That one's good. It goes through the point. -1, 3. The fourth one for D, it says y equals 2/3 times x minus 1. So that one does not go through the line, so we're not going to pick that one. What about y equals x plus 4? So that one's good as well. And for the last one, it says y equals 4x plus 1. So that one, we're out of here. That one does not go through the point, so we're not going to pick that one. So just A, C, and E are the ones that we want to pick. So let me switch back over. You can use that graphing calculator to your benefit. So we're going to say, so we said A, so it has to go through this point of -1, 3. So we said A, C, and E, where the other ones do not go through the point, so they are not possible equations to this system. Alright, flipping to the back for number 4, it says solve this equation, and it says you must show your work in a logical series of steps. So what we're going to do is going to use those inverse operations to solve for x. So inverse operations, which is the ones I'll do in red. So what I'm going to do is first I'm going to multiply both sides by 6. And you're probably wondering why I'm multiplying both sides by 6. Well, if I look at my two fractions here, I can say that, hey, both of them would go away if I multiply both sides by 6, since that's the least common multiple. So I'm going to multiply both sides by 6. Alright, so on our left side, let's draw it out like this. I can do my distributed property. I have 6 times quantity. I have 1/3 x, and I have -5. Multiplying those out, this is going to be 2x, and this is going to be -30. So I can write that underneath. So I have 2x and 30. And I set that equal to, on our right side, well, I need to say, if I'm doing half or 1/2 times 6, try that again, times 6, that's just going to be equal to 3. So what I can do now is I can do that distributed property. I have 3 times each of the terms inside the parentheses. So I have 1x and a -4. So this is going to be 3x minus 12. So then right underneath, I have 3x minus 12. So now that we did our, again, this was our distributive property. So again, make sure you're taking it one step at a time, trying to solve for x. So now that we have our distributive property done, I need to get all the variables on one side. And so I look at the coefficients of both of these terms with x in it. So I can say, well, which has a lower coefficient? Well, this is going to be 2. So I'm going to add the opposite to both sides. So I subtract 2x from both sides. So I have -30 equals x minus 12. Same idea with our constants. I need to get the constants to the other side, so I'm going to add the opposite to both sides. I'm going to add 12 to both sides. And we can say that our answer is going to be -18. And then we can say check by graphing. So how do we do that? Well, I can type in my left side of my equation, and I can type in my right side exactly as they look. So let me pull up our graphing calculator like this. Let me clear some of this out. Okay, so we said our left side is 1/3 times x minus 5, and the right side is 1/2 parentheses x minus 4. So we have to scroll the whole way out, zoom out, slide over if you need to. Notice how when we said x equals -18, notice how it goes directly through that point. And so we said our solution is going to be x equals -18, but you could say the point of intersection is -18 comma -11. So just be careful that you're saying that your answer is -18 on that one. Alrighty, so now on number 5, all you have to do is solve the system. So pull up your graphing calculator, let's graph these out. Hit the little house button to return to your origin. Type in your first equation, so I'm going to say I have 2x plus 5y equals 13. And I can say my next equation is going to be y equals 1/3 times x plus 18. So even if I don't see them on my graph, again, you should be able to zoom out or scroll over, be able to find your solution point. Real simple, find where they're equal. And so we're going to say our solution for this one is going to be, so find solution point. So we can say solution point, again, is that point of intersection. So we're going to say it's going to be -21 comma 11. So again, real simple when you're trying to graph. Find where they're equal, where they intersect, and you'll be good. All right, moving to number 6, it says Marita and Selena are each saving money. It says Marita starts with $83 in their savings account and adds $3 per week. Then it says Selena starts with $17 and adds $13 each week. So let's come up with a system of equations for that first. So let's do like this. I'm going to do purple this time. So let's say, okay, if this is our system, let's say we have Marita's equation is going to be here, and we're going to say Selena's equation is going to be underneath of it. So we say Marita start with $83 and they add $3 per week. So what I can say is, well, I have y equals, so we're going to say y is going to be the total amount, and x is going to, so let's say x equals number of weeks, and y equals savings account, or amount, you can say amount of money, or money, let's say money in account. Money in account. Let's do it like that. All right, so we have y equals, they do 3x because they're adding $3 each time. So let me just try rewriting that, 3x, and then they started with $83, so we have to have plus 83. For Selena, similar idea. They are starting with 17 and they're adding 13 each week. So we can say y equals 13x plus 17. So there's our two equations. For part A, it says after 4 weeks, who has more money in their savings account? And then it says explain how you know. So what we can do is we can, let's do this. Let's say let x equal 4 and plug it in. And the reason why we're going to do this is because we're saying, well, after 4 weeks, what is the savings account? Or what is each of their account amount? Make sure the graph isn't up. It's not. All right. So let's do it like this. Let's say x equals 4. We can say for Marita, let's do in white again. So let's say Marita is going to be like this. They have, we're going to say y equals, so we plug in let x equal 4, so I have 3 times 4 plus 83, and that simplifies, it's going to be 12 plus 83, and this is going to be 95. So we're saying for Marita, they have $95 in their account after 4 weeks. Then similar setup, let's do orange for Selena. So for Selena, their equation is going to look like this. So we're going to say y equals, they have 13, our x value is 4, so we have times 4 plus 17. So to be able to simplify this, we have 13 times 4 is going to be 52 plus 17. And we're going to say their amount of money is going to be $69. Nice. So we have Selena has $69 while Marita has $95. So we're going to say like this. Let's say, let's circle it. Let's say after 4 weeks, Marita has more money. All right. So again, be able to write, you're going from the sentences to the equations, or to the system of equations, and we're saying, okay, if x equals 4, what does that look like in their savings account? All right, so for part B, it says, after how many weeks will Marita and Selena have the same amount of money in their savings account? So what I suggest you do is graph it out. So graph the system. So what you can do is pull up your graphic calculator, have your two equations ready. So we said our first equation for Marita was y equals 3x plus 83. And our second equation was y equals 13x plus 17. All right, so even though I can't see some of these equations, I'm going to be able to zoom out, find where they are equal. We can say, okay, at that point is where they're equal. So we're going to say that solution point is going to be 6.6, comma 102.8. So let me write that down. So let me hide that real quick. And let me write that down. So again, we're saying graph the system. We're going to say the solution point. Solution point was 6.6, comma 102.8. And what does that mean for our situation here? Well, let's write it like this. We're going to say after 6.6 weeks, they both had $102.80 in their accounts. So you're just trying to find where they are equal and be able to say they're equal to. All right, for the last one, it looks like this. It says 80 people attend an activity night. Everyone chooses to do one of the two. It says either their nails, a 2-person activity, or play video games, a 4-person game. So then it says all 80 people are attending are either doing their nails or playing video games. So it's going to be one of those two. It says complete the table showing some of these possible combinations for the number of each game being played. All right, so you have to figure out what each of these groups are doing. And so what you can do first is this. Let's first let's write the system. So we're going to say the system for this, since it has a 2-person and a 4-person, we're going to say we have 2x because that's the nails group. So we're saying 2x is going to be nails, and 4y is going to be video games. And then we're saying it's in total is 80 people. So we have 2x plus 4y equals 80. So a couple different ways you can do this. You can you can plug in and solve just like we did in the last problem, or you can graph it out and try to figure it out. So I'll show you both. So I'm going to say, all right, if I split this apart, so let's split this apart. Let's do like this. Go a little bit lower. Something like that. So again, for the first one, so we're saying let y equal 4. And so what I do is I can rewrite my equation. So I have 2x plus 4 times 4. I actually do, let's do it like this. Different color. So let's say for this one for 4, so we're saying let y equal 4. So what that looks like, you have your normal equation, but instead of y, you now have a 4. So we're going to say times 4 equals 80. Now all you have to do is solve for x. So I can simplify, so this is going to be 2x plus 16 equals 80. Be able to do your inverse operations. So I subtract 16 from both sides. I'm actually doing red. So I do minus 16 to both sides. So this is going to be 2x equals 64. And then our last step is divide both sides by 2. So I can say x equals 32. So what you're trying to do is you're trying to plug in that value for the variable that you have and solve for the other one. It's the same idea with the next one. I can say, all right, let's do orange, and we can say let x this time equal 24. So when I rewrite it, again, I'm using this equation that I have right here. I'm using this equation 2x plus 4y equals 80 because that's the one that we're starting with. So I can say I have 2 times 24 plus 4y equals 80. So be able to simplify. So that's going to be 48 plus 4y equals 80. Be able to subtract both sides by 48. So on the left side, the 4y comes down. So I have 4y equals 32. Divide both sides by that coefficient, so divide both sides by 4, and we're going to say we have y equals 8. So again, it's real simple as long as you're plugging in those values for x or for y respectively. So we're going to say for this one, the point should be 24, 8. All right, let's do, for this one, we're going to say let y equal 19. So we have 2x plus 4 times 19 equals 80. So be able to simplify. When I say this is 2x plus 4 times 19 is 76 equals 80. Subtract both sides by that amount, so minus 76 to both sides. So I have 2x equals 4. And the last step, always divide by that coefficient, so divide both sides by 2. So for this one, we're going to say x equals 2. So when x equals 2, our y value is 19. And for the last one, we're going to say x equals 8. So let me plug this one in, do white this time. So we're going to say let x equal 8. So we plug it into our equation. So we have 2 times 8 plus 4 times y equals 80. Be able to simplify. So this is going to be 16 plus 4y equals 80. Subtract both sides by 16. So minus 16. So then we say we have 4y equals 64. Last step, divide both sides by 4. And we could say we have y equals 16. So when x equals 8, our y value is 16. So be able to solve them like this, or if you want to, you should be able to graph it out. So what I mean by is this. Let me pull up our graphing calculator. Clear it out. We said our equation was 2x. Hit the home button. So we said 2x plus 4y equals 80. Zoom out, find that equation, something like this. Okay, so here's our first equation. And we said, okay, well, what happens when y equals 4? So if you type in y equals 4, it graphs its own line, and you see where they intersect. So that's how we got x equals 32. We said when the next one was when x equals 24. What is it? Well, our y value was 8. Then we said when y equals 19. Again, I'm just checking all of our answers. Our point, was 2, 19. And the last one was when x equals 8. Our y value should be 16, which is that's what it is. So be able to solve those values for the variables by plugging them in or by graphing them out. Either way will work. Okay, so let me see. So let's hide this one and go to part B. So again, make sure you're seeing how to do this. Again, it was just like we did it in the notes. I told you it was going to be a test question, so that's why I'm practicing it one more time. All right, and for part B, using that same system, or let's say using that same scenario, I should say, it says there are 2 more groups of gamers than there are of people that do their nails. Then it says how many of each group are attending. So what we have to do now is we have to come up with the equation. So we're going to say y equals x plus 2. And so what you can do is you want to first write that equation. So write the equation. So we're going to write that new equation that we have, and then we need to find the solution to the system. And our system is, this equation and the one we had from the previous slide. So that was 2x plus 4y equals 80. So we have to use these two together to be able to find a solution point. So let's do just that. So I'm going to pull up our graph. I already have one of them typed in, and so our other one was y equals x plus 2. So find where they are equal. We're going to say 12 and 14. And so what does that mean for our situation? So let me hide this again, and let's write the solution point. So we said our solution was the point 12, 14, but we need to explain or show what we're saying. We're saying if there are 12 groups of nails, that means there are 14 groups of gamers. So again, be able to come up with those equations, be able to write them, find the solution, and be able to say what that solution means for your system of this situation. So again, find those steps, be able to ask questions as they come up, and as always, super slam that subscribe button.